Hello and welcome. We are Team T, and this is our capstone project. Starting off, we will introduce ourselves and the context of our project. This is our team, with myself Numair, Kior, Haydar, Alicia, and Pedro. We consist of 3 mechanical, 1 electrical, and 1 space engineers. In the much distant future, it is predicted that humans will eventually leave planet Earth and expand their territory to the further realms of the universe. But to even imagine that stage, space organizations such as NASA and the Canadian Space Agency must first research and analyze the universe nearby us first, mainly using rovers to carry out these missions. To spark interest and gather potential for the cause, the Canadian International Rover Challenge hosts competitions in which a rover must accomplish specific tasks given to them, based on various given scenarios. The York University Robotics Society is an active participant in these challenges, and have assigned tasks to different capstone groups to accomplish, such as ours. If we go through all of this backwards, our group is to provide a functional module for the YURS to equip to their rover, which will compete in the CRC and potentially aid in actual future space missions. Our given task, and essentially the need for the rover to accomplish, was to survey different areas of land for potential habitability. More specifically, it is outlined that the surveying is carried out by collecting different soil samples. There are several technical and dimensional requirements set by CRC and YURS, but the most fundamental are the following. We need to collect 9 soil samples weighing 5 to 100 grams each, ensuring no cross-contamination from the drill or the samples themselves occur, and to be accommodating with the existing rover design made by YURS. CRC conveys this information through a scenario in which an outer space settlement encounters a power outage. Let's visualize this scenario a bit closer to reinforce why this module is really needed.
This soil is the focus of our project. It begs the question, why can't the astronaut just pick it up with their hands? Why do we even need the rover for? Evidently, the soil is potentially toxic.
The next day,
the astronaut luckily has a primitive manual soil collecting tool, but of no use, as the vacuum of space sucks all the oxygen out. Back at the emergency design laboratory, however, there is still hope, as the astronaut begins creating and designing the soil sample collector module.
Here we will outline our design for Mini Capstone Day and the modifications we've made since. From the start, we wanted a modular design which was intended to be easier to implement and modify along the way. To satisfy the needs and requirements, we created 3 sub-modules with the following purposes: to drill the soil out of the ground, to carry that soil from the drill to the storage, and finally to store the different soils. As seen here, SolidWorks was used for the 3 designs, which were planned initially to all be 3D printed. The drill has a spiral inside the tubing at the bottom, in which the soil travels along to a funnel not pictured here. The accumulated soil would be carried by the transporter in a similar manner as the drill to the conveyor belt. The conveyor belt, which regulates for cross-contamination, finally deposits the soil in a rotating storage unit. Eventually, the design was modified several ways for several reasons. Firstly, the decision of 3D printing was minimized for printer, budget, and time constraints in exchange for off-the-shelf parts. The drill now slides on aluminum rails, but was still to be incorporated with tubing not pictured here. The transporter was another off-the-shelf part, with a stand fixture designed according to the desired storage height. The conveyor belt was discarded due to the redundancy of the system, however the storage unit was retained as it is.
With the design selected, the astronaut fabricates the parts and begins assembling the soil sample collecting module, prepping the rover to set out and survey the land. This is the build module. Let's discuss it a bit further.
Now we will discuss the fabricated design and demonstrate its functionalities. The drilling module is the first subsystem of the 3 subsystem design. It consists of various components including an algo drill bit, rails, brushless DC motor, and various other 3D printed parts. The 1 degree freedom system is able to move up and down in 2 stages. The first stage allows it to reach the drilling location, and the second downwards motion allows it to drill within the ground. The high-speed brushless motor provides the module with abundant amount of torque to be able to drill in a broad spectrum of soil. The soil transporter module is liable to transport the drilled soil to the soil storage system. The simple yet effective design is intended to elevate the soil from the lower drill module closer to the ground to the higher storage system. The 3D printed supports ensure the system stays at the correct height relative to other subsystems. The micro gear motors rotate the screw conveyor, which is held at the other end using ball bearings. The rotating screw then helps transport the soil. The soil sample storage unit can be seen on this slide. The whole system is fully 3D printed, allowing for a minimal weight and optimal strength. It entails of 9 different storage containers. Each container is able to collect a different soil sample. The storage system is placed directly under the soil transfer module and rotates when the soil sample has been stored in the designated spot. The rotation of 40 degrees allows for the next container to be in the right spot to store the next soil sample. The containers are removable, providing the client with the leisure of extracting the collected soil.
Carrying the build system, the rover travels to the drill site, while being monitored by the module-mounted camera. The drilling module begins its operation by lowering down and penetrating the ground. The soil is unearthed, but there seems to be a problem.
Finally, reflecting back at the project as a whole, with regards to project objective and requirements, let's look into compliance analysis. As seen in the live demonstration, for the drilling module, it does extend the drill beneath the rover profile and penetrates the ground successfully. For the transport module, it holds the soil until a storage container is available and deposits the soil into container successfully. For the storage module, it can store up to 100 grams of soil in 9 separate containers, and it rotates for the proceeding deposit. However, for the drilling module and a transfer module, we were unable to collect soil from the ground and carries it upward successfully, and we failed that requirement. In the wise word of Professor Regina, our design is a concept car that has all the bells and whistles, however does not drive. This is a proof of concept, and with some proposed improvements into soil collection system, it could work very well, as you will see in the SWOT analysis. Now let's look into SWOT analysis of our design. The modular design allows for easy maintenance and replacement of parts. It is also cost efficient to increase the large-scale manufacturing, while the total system does not achieve the system functionality. That is our weakness. However, the individual component does work. There is also concern about long-term durability due to 3D printed parts, but that can be solved using injection molding. Thus, injection molding, vacuum siphoning for soil collection, and some streamlining is opportunity for the project. We can also improve material selection to improve the long-term durability of the project. For the threat to the project design, vibrations and overheating are main concerns.
Because the soil could not currently be collected, our board astronaut will have to wait for improved future designs to continue investigating the land. This concludes our capstone presentation. Despite the technical difficulties, our group work was successful and we enjoyed our time together. We would like to give our thanks to everyone who helped us on this journey.